This is lesson 2.2 over domain and range using set notation. So I would pause this and just write all these things down. However, there's a little goofy thing the way this copied. Down here, let me just cross all this out because this is just weird. So a couple things to look over here. What is a set? It's just a collection of things. Usually in our case it'll be numbers. Example, that's a set right there. 5, 7, and 11 make a set. Now some important sets to know would be the set for all real numbers, which that's that symbol, the little funky looking R symbol, and that just means all reals. Okay, and then the set for integers would be an important one to know, and that one, it looks kind of goofy as well. Actually, it kind of looks like a double line Z thing. All these sets have somehow used two little lines in writing them. Not super duper important, but really the ones that I would want you to know would be that the goofy looking R is the set for all reals, and the goofy looking Z is the set for all the integers. Remember, integers are numbers like -3, -2, -1, 0, and so on. Okay? So again, I would make sure you paused and wrote all this down. So, a set builder notation. It's what you do is you can build a set by describing what is in the set. So imagine, you've got. You want to express all the numbers from 1 to 5. Well, you could say it's just the integers, but if you want the decimals, you can't write every single one of those decimals from 1 to 5. There's infinitely many. So you can describe a set that gets built. And that's what set builder notation is. It describes all the numbers that you want to be in the set without actually writing them yourself. And so the main important part is what you see right over here. This is kind of the basic format of set builder notation. First of all, you do have these curly brackets. That's just what I call them, these curly little brackets. Those go around your set. And you always want to lead right here with like your X or your Y, depending on if you're doing domain or range. And then this little line right here, this, it's just everything that you're going to see here is about the format of how you write it. That little line just means such that. So when you're reading all this stuff out, you would say it's the set of all X such that, and then whatever the conditions are. And some examples here is this one down here says the set of all X such that X is less than or equal to 8. So that includes all numbers less than or equal to 8. That includes 8, 7, 7.9, -79, -2003, 0.4, Then over here, on this other side, the right side, we're seeing the addition of that little symbol there. And that's where, back a minute ago over here, that's why we needed to know what this fancy Z and this fancy R, because sometimes, not all the times, but sometimes we describe the set using a specific set of numbers to pull from. And so the way that you understand this and read this is it's the set of X, and then this little symbol, it kind of looks a little bit like an E. Okay, that little symbol right there, that little symbol means is an element of, point that out, is an element of, okay? So then this says X is an element of the reals. And when I say element, that's just a fancy word for saying it is a number that I pull from real numbers. Real numbers, again, include integers, but it also includes numbers like decimals and fractions and irrational numbers. Okay. So then, again, reading this whole thing, I would say X is an element of the reals such that X is less than or equal to 7. On the flip side, had I said x is an element of the integers such that x is less than or equal to 7, that's a very different set. This set only includes the integer numbers, so 7, 6, 5, 4, 3, 2, 1, and so on, all the ones less than or equal to 0. Whereas the one that is given here, that includes all the decimals. So that's the difference between why would you use that fancy looking R versus the fancy looking Z. Well, do you only want to use integers, or do you want to include all possible numbers? That's the difference. Other than that, what you should really pay attention to here is that set builder notation is almost exactly the same as your notation that you used yesterday, just the inequality notation. We're just making it a little bit more formal, that's all. It looks scarier because of all the formalities, but it's really basically the same. So here are a couple of quick examples of set builder notation. Let me draw some pictures here. So let me make something goofy here. Let's say we draw this. Okay, now in this picture, first you want to think about this like an inequality, and we would see that for domain, it is going forever to the left, and it is going forever to the right, and most everything in between is covered except for right in the middle here. There's a big gap in the middle there. So using the example that I described, that bird's eye view, if you were a bird flying on top of this picture looking down, you would see everything to the left, you would see everything to the right, but what you wouldn't see is a little... Teachers, please pause this. I hate announcements, sorry. So we would see everything to the left, we would see everything to the right, but what we wouldn't see is there'd be a little hole right there. And so to build that set, okay, it's all the real numbers except for that one right there, and that number is 0. So I would say, and you don't always have to do the isn't X is an element of the reals thing. Sometimes you might see it, sometimes you might not. For me, you don't have to do it. It's fine. You would do it if it was just for integers, because that's a little bit more specific, but typically we're going to assume it's the set of the reals. So X such that well, how do we want to say everything but 0? There's actually a symbol for that. X not equal to 0. And this is like the main reason why I like set builder notation, is because we can say this very easy as opposed to having to write a couple of different inequalities to cover that. So set builder notation really, really great when you want to say every single number except for this one right here. And then we still need to do the range, but the range is really the same thing. The range goes forever down, forever up, and it has a hole there in the middle, and that hole is also at 0, so I would just say that the range is the set of all y such that y cannot be 0. And other things that you could put in here, I'm just going to write some without drawing a picture. I might talk about x such that -3 is less than x is less than or equal to 4. And all that means is for your x values, for your domain, that it starts at -3, but it would be an open circle, and then it goes to +4, but it would be a closed circle. So that's just how you read it, and knowing how to read is important, as well as knowing how to write it. Now, if you need more help or have more questions, you can go to that website, and I'll see you tomorrow.